Well, hello, Algebra 2. This is Lesson 11. Your objective is how do you add fractions and also how do you find inscribed angles. So that's what we're going to know by the end of this lesson. Some things to remember. First of all, when you're talking about a fraction, the top talks about how many you have. The bottom talks about how many are in a whole, or like how many pieces it takes to make up a whole, or technically the size of the piece. The top tells you how many, the bottom tells you the size. So why this is important is because whenever you're adding fractions, you need to have the denominator, the bottom, must be the same, because we add fractions that are talking about the same size of pieces. Then we're able to combine those together. And then you just simply add or subtract the numerators, or the top. And then just one more thing to remember, that any number divided by itself, like 3 over 3, is 1, 7 over 7 is 1, and x over x is 1. So a number divided by itself is simply 1. And we'll be using that principle and these principles here written in blue to go through this next part of the lesson. Alright, so first of all, we are going to be trying to add these three numbers together. Now obviously they're more complicated than like 1/2, 1/4, and 1/8 that we're used to doing before, but still the same principles apply. We're trying to find the least common multiple of the denominators. So just to do that, I've wrote out the factors of each of these denominators. So the factors of 2a are just 2 and a. The factors of ax squared are a times x times x. And the factors of ax cubed is a times x times x times x. So we need to have all of the parts to make each one of these. So notice I'm going to need to have a 2 in there so I can get that first one. All of them have an a, so I'm going to need to have an a in here. And then I'm going to need to have 3 x's. 2 would suffice for that one, but this one needs 3. So I'm going to need x times x times x. So this is just going to be 2ax cubed. It's going to be my least common multiple of all of those. So what I need to think about is I need to think about what do I need to multiply each of these by to make this one, the 2ax cubed. So if I multiply this first one by x cubed, that give me 2ax cubed. This one I would need to multiply by 2 times another x, right? Because the 2 would give me the 2. I already have the a. I have 2 x's, so one more x would give me that x cubed. And then for this last one, I need to multiply it by just simply a 2, because I already have the ax cubed there. So I'm going to apply those, what I just talked about, over here to the left. So over here, I'm going to multiply this first fraction by x cubed over x cubed. Because when I multiply 2a, the denominator, times x cubed, I'm going to get my least common multiple. So I'm going to over here for the second term, I'm going to multiply this by 2x over 2x. Again, so whenever I multiply this denominator and this denominator, I'll end up with a common denominator there. And this one over here, I'm going to multiply by 2 over 2. So whenever I multiply these, I should end up with the denominator should be 2ax cubed. K times x cubed is going to be kx cubed, plus ax squared times 2x is going to be 2ax cubed. bc times 2x is going to give me 2bcx, plus a cubed times 2 is going to give me 2ax cubed. M times 2 is going to give me 2m. And now notice that all three of my denominators are the same, which means that I can actually add these together. So this is going to be, keep the same denominator, this is going to be 2ax cubed plus kx cubed plus 2bcx plus 2m. Since none of these numerators are what we call common, means they don't have the exact matching variables in there, then we are not actually able to add any of those together, so we'll just leave them written like that. And this, as messy as it may look, is my answer. Alright, let's do the same thing again. So looking at example 11.2, I'm trying to add m over k minus b plus cx, and I just realized I made a mistake up here. This here was a minus, and I wrote it as a positive, so let's fix that. This should have been a minus, which means this should have been a minus, and this, it's not going to let me erase it. Okay, so this should have been a minus on there. I apologize for that mistake. Alright, so coming down to this one, my denominators are k, this would be a 1, and then ak squared. So again, I've written those all out, so I'm going to need to have an a, I'm going to need to have two k's, k times k, which is going to be a k squared. It's going to be my least common multiple. So to get the first one, I'm going to multiply that by a times k. To get the second one by that, I'm going to need to multiply that by ak squared, since it's just 1. And actually this last one, I don't need to multiply it by anything. So I can just multiply it by 1, or I can kind of leave that off if I want, because it already has the denominator that I want. So this one I'll multiply by ak over ak. And again, this is just a big fancy 1. Alright, these are just big fancy 1s. So it's not going to change the value, it's just changing the way it looks. This one I'll multiply by ak squared over ak squared, and this one I'll just multiply by 1 over 1, or really I don't need to do that at all since it's already there. So this is going to come out to be I guess km over ak squared minus ab k squared over ak squared plus cx over ak squared. Now that all my denominators are the same, I can add those together. So this is going to be, alright, now let's talk about inscribed angles. Before we talk about inscribed angles, let's talk back about what we learned, a review from geometry, about a central angle, which is this black one that I drew all over. This black angle goes from the center to the edge of a circle. Notice it's measured 44 degrees. And this arc that goes between its two endpoints there, what we call the minor arc, its measure is 44 degrees as well. Those two we say are the same. But an inscribed angle has its vertex on a circle, meaning it's down here, like this green one or this red one here. And the sides are inside the circle. So notice this green sides and those red sides are inside the circle. And the measure of those are half the measure of that intercepted arc, that blue arc. So if you have the intercepted arc, you divide it by 2 to get the inscribed angle. If you have the inscribed angle, you multiply it by 2 to get the arc. Interestingly enough, if you have one that has a diameter, like this picture here, it's the diameter, that means this right here is 180, is indicated. If you talk about any inscribed angle, like this, since that's half of that, they would all be right angles right there. I have 3 different ones drawn there. Each one of those would measure 90 degrees. It can be proven, we're not going to do that today. Alright, so let's see if we can find this out. First of all, let's see if we can find out what y is, because we're trying to find x and y. This y value here, and this is practice C there in your book on page 68 if you want to look at what it looked like originally. This angle here is y. So this is the arc. We have the inscribed angle, so we're going to double that to get this y. So that's why I notice we put 80 right there. So this is 80 degrees. And we know that all 3 angles, these 3 red ones here that I have drawn, all 3 of them would add up to 360 because it goes all the way around a circle. So let's just do exactly that. Let's do 4x plus 20 plus 5x plus 80 plus 80 will equal 360. Start combining like terms. 4x plus 5x gives me 9x. 20 plus 80 plus 80 gives me 180, so that equals 360. Start combining terms to the same side. Subtract 180, subtract 180. So 360 minus 180 is 180. You're left with just 9x divided by 9. 180 divided by 9. Notice that is 9, not a 90. It's going to count to be 20. So x is going to equal to 20. Alright, I hope that helps you out. Your homework is on page 68. You're doing 4 through 13 all, and then 5 more of your choice. Good luck. I will see you later.